Hi, today we are going over section 5.4, which is determining restrictions on composite functions. So we'll look a bit more at our composite functions and determine restrictions for them. So one way to determine domain and range of our function is to graph them. So, for example, we can use the functions f of x equals x plus 1 and g of x equals 4 minus x squared to graph each composite function and state our domain and range. So for each of these, I'll just create a 3-column table of values. For this first one, I'll start out with my g of x function because that's our inner function. So that will be g of x, which we know is 4 minus x squared. Now for this table, I'll go from, say, -2 to +2. So this first one, 4 minus -2 squared would be 0. 4 minus -1 squared would be 3. 0 minus, or sorry, 4 minus 0 is 4. 4 minus 1 squared is 3. 4 minus 2 squared is 0. Next, we'll do outer functions. Our outer function was f of x, which was x plus 1. So we'll just take what we had in here and substitute in for x here. So we've got 0 plus 1 is 1. 3 plus 1 is 4. 4 plus 1 is 5. 3 plus 1 is 4. 0 plus 1 is 1. Okay, so now we'll graph this. So at -2, we are at 1. At -1, we're at 4. At 0, we're at 5. 1, we're at 4. 2, we're at 1. So we can see essentially we have a parabola that opens downwards. So this was our graph of y equals f of g of x. So it has a domain of all real numbers and a range of y has to be equal or less than 5. Next, we'll do the same thing for y equals f of x. So once again, I'll go from -2 to +2. Our inner function was f of x, so I'll do that in this first column, and that was x plus 1. So -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Okay, so now we need to do our outer functions. Our outer function was f of x. So that's x plus 1 again. So we have -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. So at -2, we're at 0. -1, we're at 1. 0, we're at 2. 1, we're at 3. And 2, we are at 4. Okay, so that would be our graph of y is equal to f of x. So that's going to be domain is all real numbers. And our range is all real numbers. Okay, so to determine restrictions, write the explicit function or of composition to find. So for example, find the restrictions if f of x equals 1 over x plus 3 and g of x equals x squared minus 4x. So we know our outer function, g of x, is x squared minus 4x. And then we're going to insert this inner function into it. So that would be g of 1 over x plus 3. So everywhere we have an x, we're substituting in 1 over x plus 3. So we have 1 over x plus 3 squared minus 4 times 1 over x plus 3. So from this, we can see that x cannot equal -3. That's when we've got f of g of x. So we start with our outer function. So we've got f of x equals 1 over x plus 3. And then we are substituting in our g of x. So it becomes f of x squared minus 4x. So we're substituting this in where we've got an x. So we've got 1 over x squared minus 4x plus 3. We'll then factor this. So it becomes 1 over x minus 3 times x minus 1. So we have x cannot equal 3 or positive 1. Okay, next example, given f of x equals square root of x and g of x equals x squared minus 4, find the domain of g of f of x and f of g of x. Okay, so we'll start with our outer function. So we've got g of x is equal to x squared minus 4. Now we're substituting our f of x in for this x. So we have g of the square root of x equals root of x squared minus 4. Now, whenever we have a square root squared, what we get off is the absolute value of what's inside. So that'd be g of f of x is equal to absolute value of x minus 4. This would be x has to be equal or greater than 0 because at one point we had it inside a square root. So we couldn't have a negative value there. Okay, next one we've got f of x is our outer function. So we've got f of x equals square root of x. We're substituting g of x into it. So that's f of x squared minus 4. So we'll substitute that in for this x. So square root of x squared minus 4. We can't take the square root of this. But looking at it, we can say that x has to be equal or greater than 2 or equal or less than -2. Because those would be our two ranges that make sure what's inside our square root is positive. Okay, next writing a function as a composition of two functions. Now, this can have more than one possible answer. Now, I try to find two different mathematical operations and make each a function. So, for example, determine possible functions of f of x and g of x so that y equals f of g of x. So look at this, we've got y equals x minus 2 cubed. So we actually are going to have two mathematical functions. We have this subtracting the 2 from our x. We also have this cubing. So the cubing is done after this is combined. So that means it would be our outer function. So we'd have f of x is equal to x cubed. Meanwhile, our inner function g of x, there's what's happening first. So that would be our x minus 2. Similar to this, our square root happens after we combine these. So that's our outer function of f of x. So f of x is the square root of x. Meanwhile, g of x will be what happens first. So that'd be our 3 plus x.